All right, welcome everyone. Welcome to the third session of the day. So we have Storage Smackdown with Stephen McIver and Richie Palma. So we're excited to have them share with you guys today. If you have any questions for this session for any of these guys, please put them in the Q&A tab on the right side there, and we'll get through as many as we can at the end of this session. If we don't get to your question, we will add it to our list for the live Q&A at the end of the day today. If you have any other comments, please feel free to use the chat function, which is visible to all participants there. And then Stephen is our IBM Senior Systems Administrator, and Richie is our IBM Infrastructure Sales Consultant here at Service Express. So they're excited to talk to you guys today. So take it away, Stephen and Richie.
All right, nice to meet you, everyone. And Richie, go ahead and click on into the next slide. As you see right here, we're talking storage smackdown. And so today we're going to talk about internal storage, external storage, and how whenever you're going to purchase a new system, or even if you're looking at your current system, the struggle between, do I add more internal storage when I go to a new system? Do I do internal storage or external storage? It is like a wrestling match whenever you're coming to building the system and looking at the cost and determining what is that system that's best before I, pull the trigger and purchase it. So yeah, and Richie, actually, just to leave it on that page first for a moment, if you want to keep on seeing us right here. Richie, he's we've been a part of this organization for many years now, and Richie, he does an excellent job on the sales side of making sure that his customer is very informed on the hardware that they're purchasing, the pros and cons of what they're going with. And then myself, I'm just kind of the guy that puts it in the rack and gets it configured to get it going, doing the data migration to make sure that every one of those bits gets moved over to the other system or to the new upgrade that you're doing for your system.
Yeah, and Stephen is there to make sure that I'm not stretching my my technical knowledge too much. Keep me in line. So.
Yep. And so, today we're kind of doing this presentation sort of in a wrestling match theme. It was several years ago that Steve Pitcher and Richie, they came up with this presentation of Storage Smackdown. And they kind of went over the top in that where they actually dressed up as the wrestlers and everything. We're kind of a little tuned down today, but I have since then joined the LTO, the Linear Tape Open, kind of makes fun of the NWO of wrestling in years past. And Steve Pitcher, he has a session going at the same time right now. He's the other member of the LTO. And unfortunately, I don't have my partner here to help me against the juggernaut that is Richie Palma in this match. So
it's very strategic.
Kind of on even footing here. So I'll let Richie go ahead and start off.
All right. So round one, we're going to talk about external storage. We're going to hit on, first of all, just the overall portfolio within IBM's flash system portfolio. IBM's done a great job of, taking a lot of dispersed storage that had different features and functions, in packaging it up into a family of solutions that have a common set of, software wrapped around it. So when you look at the portfolio, we start out at the bottom with the 5015. This is kind of that low-end entry-level SAN storage. And then you get all the way up to the Flash System 9500, which is for very, very large workloads. So as you move up the family, you're getting more processor, you're getting faster drives, more caching, and then faster connectivity options and faster disk options as well. So when we look at the family, you can see there, even from a overall RACU standpoint, there are some differences in a few of these models. So with the 5015, you're looking at 24 small form factor drives. This supports SAS-based storage, but you can pack in a lot of storage into that 2U unit. So you've got 573 terabytes of storage you can pack in there. 5045, similar, just a little bit faster processor. Then you get into this 5200, which is a 1U unit, but it's your entry into FlashCore modules, which we'll talk about a little bit here because it's a major benefit to external storage. And then you get into the flash system 7300 and flash system 9500, which, carry, all the benefits of, NVMe and flash core modules in support of a larger footprint as far as drive capacity goes. So let's talk about NVMe drives. NVMe has been around for a handful of years now. It's available across the industry. One of the things that IBM has done an amazing job of and kind of differentiates them is in their flash core modules. So flash core modules, like I said before, they're available in the FS20 or 5200 all the way up to the 9500. They are IBM's custom designed solid state drives, or NVMe. It's high speed flash, which can support inline compression and offers very low latency. But it offers encryption at the flash core module level without any performance penalty to the SAN. There's a lot built in as far as monitoring for the health of the drive and making sure performance is optimized. And then with the most recent flash core module version, which is flash core module 4s, they're tossing in ransomware threat detection. So the drives are constantly, looking at themselves and looking for any signs of ransomware, which in today's world is very, very popular feature that they came out with. So when you look at all the drive options within the IBM flash system storage portfolio, they do support SAS-based hard drives, so spinning disk, and then they do support SAS-based SSDs. Where a lot of the advancement in storage has come from is in NVMe storage. So, and think of NVMe storage as storage. It's essentially the same 3D NAND technology under the covers. It's just communicating with the processor through a different form. So NVMe is connecting the processor to the PCIe bus, which essentially takes the governor off of those SSDs. So the flash core modules are basically it's those same NAND flash units packaged onto a much more robust drive. So it still has the same 2.5-inch small form factor, but you're packing on additional memory. You're packing on a lot more flash core modules, so the density of the drives are a lot higher. And then the controller on this compared to a standard SSD is much more robust. So that's where we can do compression, we can do encryption, and then that's where a lot of the advanced monitoring happens on the units itself. So with external storage, basically the way it works is you have your storage environment, which you manage yourself, or you manage as a separate unit, and you carve up ones. So you can take a RAID set of 19.2 terabyte drives, and you can carve them up and serve them up to your IBM I partitions in whatever size increment that you choose. There are ways to optimize that as far as drive size to IBM I, but you carve all those up and you serve them up to individual partitions. So one of the other kind of cool features that you have in external storage that isn't available in internal storage is thin provisioning. So what thin provisioning is you're basically you're doing virtual storage allocations instead of hard allocations. So what the SAN does is it basically kind of tricks the IBM I environment into thinking that it has more storage than you're physically giving to that individual environment. So then you end up allocating storage on demand as partition needs it. This is valuable for storage that's supporting multiple environments. So if you have a single standalone environment, this wouldn't make sense because you would end up hard allocating it anyway. But this does save money. And then one important thing is, when you're running thin provisioning, make sure that you always have the additional storage capacity to present to the individual partitions, because the last thing you would ever want is to have one of those partitions need that additional storage and you not have it to give to the partition. So just kind of a graphical look at what this looks like. So this is a typical hard storage allocation environment. So, this first environment, we're not going to go through all this, but your first environment, you're hard allocating 6.5 terabytes. It's 55% full. So you have 2.9 terabytes of storage that's sitting there, that's just dedicated to that partition, not doing anything. Same thing with the next one. It's 4.8 terabyte environment. It's 70% full. You've got 1.4 terabytes of storage that's sitting there unallocated, not being used. So in a thin provision storage environment, you're telling the environment that it has 6.5 terabytes. You're telling this environment it has 4.8 terabytes, but you're only physically allocating what it's consuming. So 3.6 terabytes, 3.3 terabytes, all the unused storage over here gets put into a bucket. It gets passed to these individual environments as they need them. So how does that help? You end up being able to not purchase a couple additional drives because you're able to, kind of ease the demand or ease the requirements of your overall storage. All right, pass it over to Steven with the LTO.
All right. Yep. I feel like I've been in the turnbuckle getting punched a few times. I'm gonna rake you in the eyes so I can kind of turn the battle back around.
There you go.
All right. Yeah, go and click on next slide. All right. So it looks like I got covered up a little bit by my little picture right there. That's okay. So yeah, also with internal storage, if you buy a new Power 10 system, or if you bought potentially a Power 9G model that came out a couple of years ago, odds are you got NVMe drives, or if you're looking for Power 10, it's going to be NVMe drives for your internal storage. And so they do come in multiple sizes, 800 gigabytes, 1.6 terabytes, 3.2, and even 6. And what it is with these NVMe drives, you're not presenting that entire big chunk of internal storage to the system, but it allows you to virtualize that storage. And so we're going to talk about this a little bit, but you're going to buy each of these NVMe drives in pairs and mirror them. And it's going to allow you to mirror these smaller spaces of storage that you're going to put on these systems. Go ahead and go to the next slide. So what is these little spaces that would normally be called LUNs on a SAN or external storage are called namespaces. And so one of the first things to do whenever you get your new IBM Power 10 is that you got to get in there and you got to carve out these NVMe namespaces to be able to add those into the disk pool and be able to then migrate your system over. And yeah, so you just have to have a counterpart to each of these. So if you've got two, actually our example right here is two 3.2 terabyte NVMe drives. You could take 16 200 gig drives, or make 16 200 gigabyte namespaces out of each of these 3.2 terabyte NVMe drives and mirror those together. And then likewise, if you wanted to make them 400 gigabytes a piece, you'd make 400 gigabyte and make 8 namespaces on each one, and then tell IBM to mirror those namespaces. And then you're ready to, for example, take a go save 21 and then restore 21 onto that new pool of disk and be able to complete your migration to the new system. All right, next slide. So the great thing about external storage is the simplicity. And so when it comes to building a new system, there's lots of great features that you're going to learn today about external storage. But then you also have to think about the complexity that it might add to the environment. And so when it comes to internal storage, you get everything in one box. And you don't need to manage and maintain extra hardware. You don't have to think about extra switches or external storage. No extra devices that need to be updated. And then sometimes it's cost is involved, and it can depend on the environment. And in a lot of environments, it may cost more to do the external storage. In other environments, it may cost more to do the internal storage. So it's always that you have to weigh and make that decision. No extra power cords required, and no extra power, no extra space in the rack. And so that can depends on how much internal storage that you need to add for the need. But if your environment's pretty light and you're using like less than 50 terabytes, and a lot of times with these internal storage, it may be less than that you want to decide to go with the internal storage, unless you decide to talk about expanding, which we'll talk about later in this bout. Go ahead and move on to the next slide. So flexibility. One thing that was always a detractor with internal storage in the past was that you had your disk backplane, and you could have it split in two. So you could buy RAID adapters to be able to connect to both those disk backplanes. But then if you needed a third partition, then you had to add an expansion drawer to have more RAID cards, and then an expansion for disk units. And so you end up having to add a lot of hardware and a lot of cables, and it got sophisticated. But now internal storage has become a little bit simpler, because you have this bay of drives that you can, and these NVMe drives, you can add them into the system just like you did disk in the past. And even the IBM itself, it's the same situation, where you can use service tools to concurrently add more disk to the system. A nice thing about this is that if you're looking at the system from even at the hardware management console level, and you're building a partition, in the past you just had to assign RAID adapters to the partition. And then if you're just solely looking at the HMC, you don't even know how many disks are behind that. Like, you have to actually physically go to the drawer and see how many disks are in that in that disk drawer or in that KEC, and determine how much space is actually going to be added. A nice thing with these NVMe drives is they show up as a separate device in, if you go into IO adapters in the hardware management console, it's a separate device for each one of these disks. And so we know that we have to mirror these at least, but you can just pick two of your bunch of disks and give them to a partition. And in LPAR2, I can give at least two to that partition, carve those up into namespaces. And if I had two more, I could put those to a third partition without having to add a disk drawer and all kinds of extra adapters. So you're very flexible in being able to assign the disk to a partition instead of having to assign it by a card. And so, again, very easy to add the storage with these new NVMe drives. And next slide. And so it's mirrored for redundancy and performance. And so we keep on saying, yes, you must use disk mirroring with these devices, because these are two big chunky cards. And so it's there for redundancy. So in case, one of the, God forbid, one of those cards goes out, you have all your disk mirrored onto that other card. And so you just have to have that other disk replaced, and then you're back up in sync and mirrored again. And in the past, mirroring has been kind of a hit on performance, but with NVMe disk drives, it really does not skip much of a beat as a result. All right, next slide. And now we're back to Richie.
All right, round 3. All right, so external storage. Another great feature within external storage is distributed RAID. So what distributed RAID does is it enables all the drives in the RAID set to contribute to performance. With traditional RAID, you would typically allocate, a drive or a couple drives to be hot spares, and with distributed RAID, you basically create those hot spares across all the drives themselves. So where you really get benefit from this is in the event that you do have a drive failure on the SAN, you're talking about 5 to 10x faster rebuild times compared to traditional RAID, because you're not hammering that one drive and building that, on that one drive. So RAID expansion is also a major benefit for distributed RAID. Typical RAID set with internal storage, you're kind of stuck with what you built on the front side. As far as a RAID set goes, you can't just add 1, 2, 3 drives to a RAID set. With distributed RAID, you're able to do that. So the nice thing is, once you've already kind of said you're going to have in your RAID set, you're going to have your RAID drive, a couple hot spares, Any drive you add to that rate set after that is just additional capacity. So you're not really sacrificing much capacity when you're adding those additional drives. Typically, at least as far as, a lot of the configuration that we put together or that I put together over the last 10 years, it's typically we connect SAN storage to IBM power system through fiber switches, but you can direct connect it. So if you want to direct connect, it's simple connectivity. You're connecting the SAN directly to your power system. Unfortunately, when you do this, it really limits your ability to scale, because you have to have you have dedicated cards that are connecting into that SAN. If you connect via fiber switches, it creates a lot of benefits from an ease of future migration standpoint. So we'll actually talk about that a little bit later here, so I won't touch on it now. You can add additional fiber attached components like a tape drive or VTLs to your environment through the fiber switch. And then there's smart downgrading for different speed cards. So with Power 10, we had a little bit of a situation when it was released where Power 10 would not, it didn't talk 8 gig fiber. So there really wasn't a card to support an 8 gig fiber connection supported on Power 10. So in order to early on, it's been corrected now, but early on, if you wanted to connect to, say, an 8 gig fiber tape drive, or you wanted to connect to, a VTL that required 8 gig fiber, you would have to go through a fiber switch. So 16 gig fiber switch that would kind of dumb that down to 8 gig fiber. You can virtualize storage via BIOS. So virtual IO server, this is a virtualization technology that IBM created. Steven is a guru as much as he's repping internal storage right now. He is the BIOS king. So I can't believe I'm talking this slide and he's not. But so it helps maximize the use of physical resources. So when you have virtual IO server, you can stack up a few fiber cards. You do that. You want to have enough so that you have redundancy from a fiber card standpoint and redundancy through switches. But by virtualizing those connections, you remove the requirement to have dedicated cards for partitions. So it creates a very scalable environment. One of the nice things that I see with customers, and I had a customer recently who they acquired another company, and they wondered what it would take from a hardware standpoint to move this other company's environment or their 2 LPARs onto their infrastructure. Well, they ran BIOS, they ran external storage. My answer was, you should probably turn another IBM iLicense core on, because they already had enough storage to support the customers to the company they acquired, their 2 environments. And it's as easy as, turning up some virtual connections and carving up additional partitions. So, and you could do that over and over and over again, as long as you had the disk or the storage resources and the compute resources to do that. So it gives you flexible allocation and reallocation of IO resources without disrupting operations of other environments. And then we always build BIOS in pairs, at a minimum in pairs for redundancy. Nice thing there is you can actually, if you've got to upgrade BIOS, you can upgrade one side, and then bring it back up, upgrade the other. If you lose one BIOS environment, the other one takes over. So when we build out infrastructure, we always focus deeply on having that redundancy throughout the stack. Encryption at rest. So hardware-based encryption. So this is encrypting the actual data that lives on storage. We have FlashScore modules, which we talked about, which do encryption at rest right on the modules itself. This leverages dedicated encryption, or excuse me, we can also do it through dedicated encryption processors that are built into the storage controllers to limit, how much taxing is done on the actual processor within the SAN. And hardware-based replication or encryption at rest, hardware-based encryption or encryption at rest basically makes the data or the disk unreadable if anybody physically took that SAN storage and plugged it in somewhere else. It minimizes impacts on performance. For encryption key management, there's tools and capabilities for generating, storing, and securing and managing encryption keys. And this also tends to be an area where businesses have to support some sort of compliance requirement. And so, the easiest way to make this happen is for a company to move to external storage with encryption. And this is something that's not super easy to do from an internal storage standpoint. One of the other benefits that we see for customers who want to move to external storage is the SAN can provide storage across platforms and OSs. So a lot of times, an IBM iShop, maybe they have 1 to 2 terabytes of storage, and it doesn't make complete sense for them to make the move to external storage because they do have to manage another device. But to share some of the cost burden for that, they may say, okay, we're going to get a bigger SAN, and we're going to also support our x86 environments from a single storage device. We always suggest that they are on completely separate RAID sets and drives, and physical drives, just because there is a difference, between how IBM I talks to disk and how x86 talks or works with disk. So we always suggest you keep those things separate. With that, you get centralized storage management, so single pane of glass for all your storage, x86, IBM I, if you have AIX, any Linux on Power, you have this, that single pane of glass for all of those environments. And with that, you can sometimes find a significant cost savings because you don't have separate storage environments for each one of those environments themselves.
All right. Back to me again. So yeah, now I got to do something to get back into this fight. I'm starting to get pretty wary here, but I'm going to catch my second wind and come back swinging.
There you go.
Yep. So yeah, let's talk about the NVMe expansion drawer. This wasn't immediately available, but came soon after Power 10's release. And it's got the best name. Like, you should just buy it for the name alone. It's called the NED 24. But it allows you to expand the number of NVMe drives that you can have on the system. So once you've loaded up the main unit, if you still need more NVMe space for internal storage, it gives you another 24 bays to insert. And so if you got the biggest drives and fully populated this thing, you can add up to another 153 terabytes per drawer. And so you can keep on adding those. Again, adds more to the complexity with having to add a whole bunch of extra drawers. But if you do need that extra space and you want that internal storage, you do have the option there. So you're not limited by the space that you have there in the KEC or the main unit. All right, next slide. So Richie was talking a lot about being able to virtualize with the external storage, but the truth is you can also do virtualization using the internal storage as well. And so you can do that either through IBM I or through Virtual IO Server using what's called Virtual SCSI. And anytime we say virtual, it just means not real, or it's using a SCSI interface, but there's not an actual SCSI interface there. It's just traveling all across the inside of that Power 10 system. So IBMI, hosting IBMI, been around for a long time. That allows you to carve up disk any size you want to and serve them up to the clients. So here you would give your internal storage all to this one IBMI hosting server that you've dedicated. And then from there, you can carve up storage spaces on it, or like LUNs on that system, and then use virtual SCSI to hand those carved up drives to your other IBMI clients. And drive size still does matter, because the minimum size for a load source disk is 35 gigabytes. And of course, we can make those quite a bit bigger than that. So don't make the drives too terribly small. Don't go too crazy with cutting them in a very small size. And then you can also do it with virtual I/O server. So in the very same way that you can do it with IBMI, you can create two virtual I/O servers on your system. And virtual I/O server, the I/O stands for input output. And so typically your input and output adapters on a server are your Ethernet, your network adapters, and then oftentimes your fiber adapters for being able to connect off to tape or disk to send that data in and out of the system. And so you can create two virtual I/O servers. You can assign NVMe disks to those, and then from there you can then carve those spaces and then hand them off to client partitions. And with virtual I/O server, again, you get the great benefit of being able to do maintenance on one virtual I/O server while the other virtual I/O server carries a path to all the disk. And so you don't have any downtime. That's like the one big detractor of IBMI hosting I, is that if you got to maintain the IBMI hosting I server, then all the clients got to come down for that. But definitely, I hosting I is definitely it's been a fun way in the past. And nice thing too is that you can have, for instance, you don't have to have a dedicated IBMI hosting I server. In many cases, places will have their production server, and they'll just use it to carve off a little bit of space and have a development partition. And so sometimes it's just a very cost-effective way to gain another partition to be able to do some work on. All right, next slide. And so we do have high availability on internal storage. So this isn't something that's only limited to external storage. Even on internal storage, we can do hardware-based replication, and we can do that through the power of using PowerHA. PowerHA has a replication technology that's called GeoMirror, and there's a lot of times that, customers that get up in cloud environments, sometimes they're using GeoMirror even despite being on external storage. But if you had a Power 10 scale out server, you wanted to put a Power 10 scale out server, you can put it right next to it if you want to, but many times people will put it in a different physical location just because if there's a site disaster, they want to be able to swap over to it. But yeah, GeoMirror allows you to put your important data into an independent storage pool on the system and be able to replicate every bit of that to the other system and use administrative domain to get everything else that you need in the sysspace to be able to replicate to another site. Also, there's just a myriad of software-based replication tools that are out there to help keep that data in sync, to be able to easily facilitate a role swap to another site in case the worst is to happen, or if you just want to plan and be proactive, be able to operate a different site for months at a time and go back and forth. And so also whenever you have this HA posture, you're able to utilize the replication target to do cool things like full system backups. So you can say, hey, stop replication for a little bit so I get this point in time of my data, back it up, and then go ahead and resume replication so that everything gets back in sync again. And even too, what's cool is using it for upgrade purposes. So you can upgrade your target system first, and then you can instantly complete your upgrade of your production by just role swapping over to the target system. So as soon as you've role swapped over to the target system, you're on the new level of IBMI, and then from there you can proceed to upgrade the other system that's normally the production system, and then swap back to it some point later. So that's all tools that you have available to you on internal storage. It's not something exclusive to external storage. So there are options out there for that. Next slide. So managing your storage from IBM, and so a complexity that comes along with this is that if you're buying external storage, this is its whole separate appliance. This appliance comes with a new piece of software that you may have never seen before, and so you have to learn how to use a new graphical interface. It can be a little daunting at first when you see all the different options that you have to click on, so many things to look at. Then along with this, you have new user credentials. So if you had a team of 5 admins on your team, then you end up going into this new device and you have to create credentials for all those users as well. So it's another pain where you have to manage more users now, given it does have the option to be able to tie into LDAP. So if you wanted to, you could tie it into an LDAP server, and so users could use their same credentials on the network to connect into that external storage system. But it is just another interface to log into. You can manage these cool new NVMe disk just the same way that you've managed disk in the past. If you're in IBM on the green screen and you simply type in the good old work disk status command, you'll see all these NVMe namespaces appear just as you would see disk in the past, and you can see how busy they are, and that disk IO performance. And also the good and new navigator allows you to look at the collection services to see all that disk data and all those great charts that it collects. And so those charts that we're collecting for disk units of the past are also doing the same collections for the NVMe disk now. So if you've been used to looking at your performance in there, and then you can still see it the same way, and maybe use some other collection tool that's pulling that data from IBM, it's going to pull it the exact same way. So you can still review performance just the same. All right, next slide. So again, simplified maintenance and support. No need to have maintenance on another device. And so if you have just the Power 10, you've got maintenance on the Power 10. And if you got external storage, you got maintenance on the Power 10, and you got maintenance on the external storage device. So it can cost a little bit of extra money to maintain the maintenance on the other device. Only one contact that needs to be made on all hardware in the power system. So whenever you phone IBM and you got a problem with the disk, you're calling the hardware support, you're telling them serial number of the Power 10, and they're checking the maintenance on that, and that's the end of the story right there. If it's a hardware failure that happens on the SAN, and fortunately on the SAN, you should be configuring your unit to phone directly to IBM, and it all gets taken care of for you. If for some reason you needed to contact IBM for maintenance on the external storage system, that's a different serial number other than the Power 10 system. So keeping track of those serial numbers, the list to get your support ticket put in. Less devices to worry about and to support on. So every device, and just like our lives, we're all going to die at some point. Every device that's ever been created is going to go into support at some point. And so that's another thing that's weighing on your mind that you have to think about. You buy a new device, okay, 5-6 years from now, I have to have a plan to be able to move this off onto something else. And so it's just another device you have to consider with that. Simply less devices equals less points of failure. And so if you got the SAN that's out there, that's just a whole bunch of hoops where you can have cards fail, ports fail, something drops, and it's some other thing to consider when you're trying to troubleshoot a problem. So sometimes having a simplified environment can make it easier to pinpoint where a problem's happening at. Lastly, it's just all your eggs aren't in one basket now. Nice thing with external storage is definitely having on external storage, it comes in the flash systems that we're talking about, comes with 2 nodes. So you're not completely done for if a node on an external storage system goes bad. You still are propped up by the other one. But still, if someone just came and unplugged the SAN, then everything that's connected to that SAN is out. Whereas if you had multiple, Power 10 servers, you got different pools of those disks, so that one system accidentally became unplugged, it's not the entire environment. So it's just one of those things to consider whenever looking at the internal versus external storage. Now, if it's 1-for-1, if you just have one SAN and then you have one system with disk in it, your eggs are still in one basket. But if you got multiple servers, it's something to consider. All right. Next slide. I think it's back to you, Richie.
All right. Perfect. Round 5. And I saved
I'm
best
worried
for
that Richie's
last.
about to throw a finishing move on me.
Yep. Off the top ropes.
Yep. He's climbing
All right.
up.
Yeah. So we talked a little bit about compression, or we talked about encryption. Now we're going to talk a little bit about compression. Compression and external storage allows you to get more bang for your buck. So there are a couple ways that we can do encryption, or excuse me, do compression with external storage. The first is, having the SAN controller actually do the compression for you. You let the SAN unit itself do the compression. This consumes some compute to accomplish this. On some of the bigger SAN storage devices, they actually have some dedicated processing cards that do some of the compression for you. This is typically used in environments that have standard hard drives, SAS-based SSD, or just straight NVMe drives. Where flash systems really kind of differentiate themselves is in the flash core modules themselves. So we talked about that earlier, but the flash core modules do compression on the individual module or drive itself. So this is all handled through the controller on the flash core module. There's no performance penalty or degradation to the SAN storage at all. And then IBM actually offers a guaranteed 3-to-1 compression for flash core modules. This is something where obviously depends on the workload. If you've got a bunch of video files on a flash system, unfortunately you're not going to, those are already compressed pretty good, so you're not going to get 3-to-1 compression. But typical customers are gonna get better than 3-to-1 compression when they're on flash system with flash core modules. The next thing is, let's see, did I go twice? No. The next thing is flash copy. So it used to be, for external storage, the biggest driver for people to make that next move to external storage was encryption at rest, because it was a compliance, typically chasing a compliance requirement. Exit out of this, sorry. But nowadays, with 24/7 operations and the demands on systems in the business, I would say probably the biggest reason people move to flash system storage is for flash copy. So a flash copy, you basically are creating a point in time copy or snapshot of volumes or logical units on your storage. So for an IBM shop, if they're running an IBM environment and it's completely running on external storage, you're able to nearly instantaneously create a point-in-time copy of that environment. What you end up doing is you create a point-in-time copy on a separate partition that you have, and then you have a controlling partition that keeps the consistency for that point-in-time copy, and then you can use that copy of the environment to do a backup or to do testing. You could flash out a copy for development partition, even do things like analytics if you wanted that one point in time version of the data, so people aren't arguing over certain metrics within the business because they were done at different times. And then you can also use it for disaster recovery. So with flash copy, we always suggest using the flash copy toolkit from Lab Services or Expert Labs now. It offers flexible management tools and interfaces for managing flash copy snapshots. So you can do flash copies without it, and you can create and custom build everything on the backside to do a flash copy. We always suggest to our customers that they purchase the toolkit alongside the flash system if their goal is to do flash copy backups. It really, for the price, it really offers a great interface and great integration with a lot of the other things that are built into like your backup process. So BRMS, then it allows an administrator who doesn't maybe understand the ins and outs of the flash system to create, schedule, and manage snapshots operations really easily. It has capabilities for creating multiple snapshots. You can define your retention and the restoration of data all through the lab services toolkit. So now taking flash copy a step further, this came out in the last couple of years, but it's called safeguarded copy. So within IBM flash systems, they have a solution that's called safeguarded copy that's really built around resiliency for like cybersecurity situations. So what safeguarded copy does is it automatically creates regular scheduled immutable backup copies for you based on whatever schedule you choose. So immutable means it cannot be written or read by an application. So it's a walled off snapshot copy of your environment at any point in time. So you can automatically create these and delete these based on whatever predefined schedules you build. And then you isolate it and air gap these copies in a defined way. So for example, these air gap copies could be set so that they aren't accessible until you have, two people with certain credentials that are able to log in and release that to be rebuilt. So there's also proactive monitoring for signs of attack. So within safeguarded copy, it can go out and look at all the volumes that you created, and maybe you're taking a snapshot every 30 minutes. And it will go back and it helps you look for the best recovery point, and then kind of fast tracks the restoration of those copies of data onto your primary storage. So the thing to think about when you talk about safeguarded copy is that it's not there to prevent you from getting ransomware or prevent you from being attacked. There are other products that help you to put yourself in a position to do that. What safeguarded copy does is it drastically speeds up your ability to get back on your feet after you've been knocked down by a ransomware attack. And a lot of times when you look at your ability to recover, rebuild after you have an attack, if you can save yourself weeks or even days in that process, that means a lot to the business and the survivability of your business. So what's required for safeguarded copy? Well, you have to have flash system external storage. You will require additional storage capacity for those safeguarded copies. You can use the storage modeler to be able to, build out based on some, whatever you define for retention, and you can size up the storage so that you make sure that you're covered. You need a flash copy license. Nice thing with flash copy now is it's included in pretty much every flash system model. And then you need to have some sort of idea of how you're going to create or how you're going to structure the automation and scheduling process. And then you need to decide how you will factor in additional security measures to prevent safeguarded snapshots from being used. So that's where you have the multiple people who need to log in and approve, the recovery of a safeguarded copy, things like that. All right, the next one is full system replication. So, I would say number one reason now for moving external storage is flash copy and shrinking and removing that backup window. The next would probably be full system replication. Encryption, we talked about that earlier. That's easy. That's just kind of checking a box on the front side. But when you look at the value of SAN storage, full system replication for high availability is probably, it's right up there with number one reasons why people move to external storage. So you can basically replicate all your storage from one SAN to another SAN. You can do this through the full system replication toolkit from Lab Services, and that helps you to facilitate swaps. And then one thing about full system replication is it does require an IPL during the swap, so it isn't true high availability, because you have to be able to tell which environment comes up as a production environment if you're replicating between the two environments. You also have Power HA high availability. So with Power HA, you're able to offload the replication to the SAN storage. This requires you to transition your applications in your environment to using independent ASPs. You have options for different types of replication. So you can do GeoMirror, Global Mirror, or Metro Mirror. And then you can also stack Power HA high availability or Power HA replication up next to like a software-based replication solution to replicate things that don't fit well inside of an independent ASP. One of the concerns people have about the move to external storage tends to be focused around how do you get there, right? So, and I definitely need to update this drawing here, but when you're moving from internal storage to external storage, it's a lot less daunting than what people think. So one of the benefits that IBMI has is it knows where everything is on disk. It also allows you to serve up storage to the individual IBMI partition from different RAID sets or even from different types of storage. So what we can do is we can connect the flash system storage or the SAN storage to IBMI and present those LUNs to IBMI. And then we can let IBMI move disk from the internal drives. We can let it slowly drain that over to the external storage. Once the internal storage is completely drained of the storage, the only thing that we need to move at that point is the load source. And that does require a short outage. But once that happens, you're completely running on the external storage. So very short outage window. It isn't a save and restore type migration to make the move to external storage. So decoupling the storage and OS from the processor. So once you've made the move to external storage, there are some significant benefits to future migrations for both the IBM Power system and the storage itself. So for IBM Power, if you have everything living on external storage, it pretty much becomes plug and play for the migration. So say you have a Power 9 machine with a flash system underneath it. All you end up doing is you bring down the Power 9, physically move the fiber cable connections to the Power 10 and bring up the Power 10. It requires a small outage, but it's much less painful than if you had to do a save and restore migration going with internal storage. On the SAN side, so future SAN storage migrations, so storage, so Spectrum Virtualize or uses a tool that's built in called transparent data movement, and it essentially, and I think I have I didn't have a drawing in there for that, but essentially what it does is it allows a new SAN to kind of sneak in between the power system and the existing SAN. And the existing SAN becomes virtualized underneath the new SAN. And then once that happens, then all the data that lives on that environment can be moved from the old SAN to the new SAN. And once that data is moved and it's all done under the covers, it does take into consideration SAN performance. But once that happens, then you can remove the old storage. First, with some of these models, you can actually even keep that storage virtualized underneath that existing, or that old storage underneath the new storage, to just maybe you want to archive stuff there or use it for something else. The nice thing here is by decoupling the storage in the OS from the processor, you're able to offset some costs. So I have customers who they'll purchase a power system, and then a couple years later, they'll purchase SAN storage, and a couple years after that, they'll upgrade their power system. So they're kind of balancing the costs, across a couple years, and they don't have that one massive purchase every 3 to 4 years. All right. Do you have any questions?
Yep, I saw there's a few questions out here. I'll start with the first one. This is, how do you benchmark or stress test large 2,000 plus volume ASP multipath storage configurations? That I would definitely recommend a professional on the IBM storage team to be able to get you the proper benchmarks for such a large system. They probably got something in their environment that they could try to benchmark for that to get you some numbers.
Yeah, so we work. Oh, sorry. I was going to say we work very closely with our storage engineers and storage reps. So you could reach out to us, and we can facilitate all that for you.
Mm-hmm. And sometimes if you have odd questions, sometimes we're able to reach out to experts there at IBM to get the straight answer to be able to get you a very good answer. What adapter allows direct fiber connection on Power 10 to take disk? And I think just about any one of them. I know that if you're using the system planning tool, it's probably going to make sure that you get an adapter that'll work just fine. But I don't know if there's any in particular, Richie, that there's like a specific adapter. I think pretty much all the fiber adapters allow for the direct connect.
I wonder if they're talking about to like an 8 gig tape drive.
Yeah, there's definitely a consideration for that. All of the new flash systems, I think most of the new flash systems, and there may be an option too. If like a flash system typically has a 32 gigabit card now, I think you can even put in a 16 gigabit card if you really want to. But if you were buying a new Power 10 system and it was just direct connecting, I'd say get the flash system with the 32 gigabit and put 32 gigabit fiber cards on the Power 10. You can just directly connect into that, and you're not going to have any issue. But yeah, definitely matching up the speeds. The nice thing about a SAN switch is that it gives you SFPs to load into that SAN switch, and those SFPs can account for different speeds. So in the past, like when we're talking about attaching a tape drive to a switch, if you got an SFP that supports 16, 8, 4 gigabit speeds, then it's able to take what's coming from a 16 gig card, downshift it to an 8 gig card to go to a tape. Because when those speeds don't align, then you got things like a tape drive that just won't work. It says power server with SAN attached via Brocade switches. What are the implications and requirements for adding a second SAN to the existing config? And with a second SAN, I assume maybe you're wanting to migrate to the new SAN. Because if you got an existing SAN, you probably just add some more storage to that to be able to increase the storage. The nice thing is when you've got that set up and you're moving to a second SAN, then yeah, you can use the SAN switches to network the two SANs together in order to do the ability to make the new SAN a front end for the old storage on the back end and complete the copy process to the new SAN. And so it's actually using that method as a very small outage for IBMI to start the copy process. And then once the copy is started, then you can fire the system back up, and you wait for the copy to complete. You hit finalize on all the copying disk, and no more hiccups, and off it goes.
Yeah, I know we just hit time here, but I'll grab this one question. Are snapshots meant to replace traditional LTO backups or used in combination? So snapshots reduce the need to have a big outage window to grab that point in time copy or to create that point in time copy for backups. So you can back that snapshot or that flash copy up to LTO tape, just like you're doing today. The benefit is that it allows you to release the source side back to productive use as soon as that snapshot's created. So you could back up to LTO tape, you could back up to virtual tape library. It doesn't matter from a backup standpoint where you're saving it. It just limits the outage window you have to take to do it.
Yeah, and lastly, a snapshot is the entire system. Whenever you save to like an LTO tape or virtual tape, it saves it at the object level. So if you just need to restore that one file, then you can get that off of the tape a lot faster than you can bringing the whole system up from a snapshot and then still having the box set up. And so, yeah, there's a great benefit to saving at the object level to get those individual important files back if necessary.
Awesome. Well, thanks so much, guys. And thank you everyone for attending this session. So we're going to take a 15-minute break here, and then we'll head out into the breakouts portion of today. So if you had a question in there that didn't get answered, we will make sure to put it in for the live Q&A at the end of today. And then, yeah, we are looking forward to seeing you in the next sessions. Thanks, guys.
Thank you all so much.
Yep. Thanks.